So we already know that for the gradient of a line is change in y over change in x. And if we've got the coordinates of that slope to work out how steep it is, then we can say, okay, change in y, that's y2 minus y1 over x2 minus x1. Okay, and that's a formula you just have to know from NAP 5. And on the introductory task, I think everybody got those completely correct. But just to fill in your notes there, here's a wee example just to make everything complete. So gradient of AB in the diagram, change in y, minus 2 minus 5 over 6 minus minus 1. Okay, which works out as minus 7 over 7 equals negative 1. A little sketch is often very good just to check that your answer makes sense. And sometimes people get confused as to, they sometimes maybe do 5 take away negative 1 or something silly like that. Okay, so sometimes it's handy just above each one to put. I'm choosing this as point 1. So I'm going to call this x1 and y1. All right, and this is point 2. So I'm choosing this as x coordinate 2 and y coordinate 2, just to make sure I've got the right things in the right place for when I plug it into the formula. Okay, but it's entirely up to you whether you write this in or not. Okay, but as I say, it's sometimes a good idea if you sometimes mix these numbers up. And the second thing is, it doesn't matter which you call point 2 and point 1. All right, I've called the first one point 1 and the second one point 2, just seem to make sense. But if you want, you could call this one point 1. Just if you swap the two numbers on the top here, make sure you also swap the two numbers on the bottom there. All right, it will still work out to give you an answer of negative 1. Okay, the new bit for higher goes as follows. All right, let's say I said to you on this diagram, work out this angle here. Okay, now there's a funny little symbol in here, theta. Okay, so I'm going to have to find a little sheet which explains what these things are. Basically, in maths, we ran out of our letters. Okay, so we said, well, okay, our alphabet's not enough for all the different symbols we need in maths. That's okay, there are other alphabets. There's the Greek one. We already know Greek letter pi, okay, ratio of the circumference to the radius, to the diameter of a circle, all right, roughly 3.141592, blah, 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 blah. All right, other Greek letters we use from time to time, all right, which gave us the letters we have in our alphabet, all right, they changed over the last 2,000 or 3,000 years. Greek letter alpha, Greek letter A, all right, there one there. All right, Greek letter for B is beta, looks like that. You can see how our capital B came from that over the years. Okay, and indeed put the two together, alphabet, that's where we get the word alphabet from, because it's the first two letters in the Greek alphabet. Greek capital H looks like this. Again, over the years, if you use your imagination, you can probably see how that became a capital H. But actually, all right, gave them a th sound, all right, TH sound there. And so this letter is called theta. In fact, if you look at the word theta, there is a word the, which is the main word that begins with the, that sound, the TH sound, okay, is theta. We use this in maths a lot for an unknown angle, all right? So just like in equations, we often use an x, okay? If it's angles, all right, in higher and beyond, university, etc., engineers, we use theta. So when talking about theta, all right, it's basically like a capital O with a horizontal line through it. Okay, so that's an angle. All right, so if I said on this diagram here, work out angle theta, all right, you'd go, oh, I can do that. It's a right angle triangle, all right, tan opposite over adjacent, 3 over 15, 3 over 15, okay, shift tan, and you get 11.3 degrees. Okay, easy and straightforward enough. However, if I also had said not work out the angle theta, but work out the gradient of this line, of this slope, you'd say, well, gradient of the slope, all right, change in y, that's this side here, over change in x, that's this side here. Oh, you see that's easy as well. Gradient, 3 over 15, okay. Change in y over change in x, all right. Change in y was 3, change in x is 15, 3 over 15. Oh, but that's the same as we had here. Tan theta is 3 over 15 because it's opposite over adjacent. So that means if they're the same thing, gradient is tan theta. The angle with the horizontal in our diagram here, right? Always this angle here, the angle that the line or the slope makes with the horizontal, the tan of that angle is the same thing as the gradient. So we have another method for working out gradient, all right? Change in y over change in x, or tan theta, So we should be putting that into our notes. So there it's there. So in the second box in your notes, your top half of your notes, fill in that, please. The second half of your notes, crucially, gradient, another way to get it, tan theta. That means that if we know the gradient, we can work out the angle that the slope makes with the horizontal. Or if we know that the angle, then we can do it the other way around and work out the gradient. So, for example, here, all right, you can scribble this on the back of one of your note pages if you wish, but I think it's fairly straightforward, I hope. What's the gradient of this line JK? All right, so there's my line, okay. Doesn't really matter where the points of J and K are on it, so long as it's a straight line. So let's say J happened to be down here and K up here. All right, what's the gradient? Well, I know it's making 42 degrees with the horizontal. Oh, but therefore, gradient equals tan theta. So that's tan 42. Reach for my calculator. All right, make sure it's on degrees for goodness sake. Tan 42, there we are, 0.900. All right, so the gradient is 0.9. It's a perfectly acceptable gradient. Let's do it the other way around. Okay, what's the size of angle theta here? Well, I know that the gradient is 3 over 13, the question tells me. What's the angle with the horizontal? The angle with the x-axis, or OX. Tan theta is 3 over 13. Shift tan, 13.0 degrees. Nice exact numbers. Of course, we chose them specially. How does it work out in practice, in higher exams and contents and questions? Well, in the example on the second page in your sheet, okay, what angle does the line joining 3, 4 and minus 1, 1 make with the positive x-axis? So, stick a little sketch in here. Here's my negative 1, 1. Here's my 3, 4. It's just a sketch, it's not that accurate. By the way, make sure you put in x and y. Should always be on your diagrams. Okay. Gradient, change in y over change in x. All right, works out. Plug in the numbers. 3 over 4. Oh, but gradient, that's tan theta. So I can say here, okay, gradient, yeah, but I'm going to replace that with tan theta. Tan theta is 3 over 4. Oh, so shift tan, 36.9 degrees. Second example, just like the one I showed you. Okay, this time I notice when I put in my angle with the horizontal, 135 is more than 90, so my line is coming down the way. So I'm expecting a negative answer, because that's how that looks. Gradient is tan theta, tan 135, reach for the calculator, negative 1. Talking of positive and negative gradients, a little reminder, fill in your notes please. Okay, lines that slope upwards from left to right have a positive gradient. Likewise, lines that slope down from top left to bottom right, okay, right is seems to be there, so I've just moved it over to the word, have a negative gradient. Okay, something again you should know from Nat 5. Moving on, all right, just to fill in sheet 3 of our notes, okay, on here, all right. Lines parallel to the x-axis, so a line like this one here, the gradient is 0, okay, there's no slope at all, it's okay, it's going along nice and easy horizontally, so the gradient is 0. Any line that's horizontal, what's the equation of it? Well, if I said, for example, that this is the point 35, that would be the point 45, 55, 65, 05. All the y-coordinates are 5. So the y-coordinate stays the same for a horizontal line. All right, so I've said equation of the line is of the form y equals c, where c is some constant number. Obviously, this one is y, I said could be 5, but what if it was 7? What if it was 22? It's always y equals. Fill in your notes. Okay, example number 4. Okay, lines parallel to the y-axis, like this one here. Vertical. Now, if you want to use your tan theta on there, you try putting in tan 90, because that's the angle. Tan 90, changing y over changing x. The change in x is 0. Right? And you can't divide by 0. So we say the gradient is undefined. That's one of the reasons why if you put in tan 90 on your calculator, it will come up error, because there is no value. It's an undefined gradient. So the equation is x equals a constant. So this could be, if this is, for example, the point 40, that'd be 41, 42, 45, 47, 412. The point is x is always 4. Of course, it could be on the other side of the y-axis, and so it could be x is negative. Not a problem with that. And so on. And then finally, parallel lines, by definition, have the same gradient. In fact, if we can say that two lines have the same gradient, it also does at the other end and proves they must be parallel. So how does that work out in a higher question? The example in the bottom of sheet 3 in our notes. Okay, we've been given the coordinates of different points, A, B, C, D. So I've marked them on my diagram, A, B, C, D, worked out which one was which. Okay. How do I show it's a parallelogram? Parallelograms are defined as shapes that have opposite parallel sides. If the opposite sides are parallel and it's four-sided, they must be the same length. So I just need to show the opposite sides are parallel. So work out the gradient of AB and the gradient of CD, or DC if you prefer, and hopefully they'll be the same. So using the coordinates, changing y over changing x, gradient of AB works out as 4 over 3. Gradient of CD, no, surprise, surprise, also works out as 4 over 3. So I can say the gradient of AB equals the gradient of CD. Therefore, AB is parallel to CD. You kind of have to say that. Because I see the parallel, the gradient, because the gradients are the same, that means that they're parallel. You should state that. Likewise, gradient of BC works out as 2 over 3. Gradient of AD, changing y over changing x, also works out as 2 over 3. Oh, that means the gradient of BC equals the gradient of AD. Therefore, BC is parallel to AD. And then conclusion, oh, opposite sides are parallel, therefore it's a parallelogram. Right. And that should complete everything we need on the notes and everything you need to do for straight line task 1.